In this video, I'll talk about how to handle powers of sine and cosine, and I'll do that in part by doing this particular integral. The integral of cosine squared times sine cubed. Now for this particular one, if we pick u equals sine x, the problem is we'd get a u cubed, but then we wouldn't have a simple du. We'd need a single power of cosine. And unfortunately, we have two powers of cosine, so this doesn't work so well. But suppose we pick u equals cosine x. So we have a u squared here, and two of the powers of sine we can change to cosine via the Pythagorean identity. So for example, we could rewrite this as cosine squared times 1 minus cosine squared. That accounts for two powers of sine there, and we're left with just a single power of sine. And now we're in great shape, because now the derivative du is negative sine x dx. So we just need a negative sign here, and we can get that by reversing the order of subtraction. So cosine squared x, and then cosine squared x minus 1, and negative sine x dx. And now this becomes simply u squared times u squared minus 1 du. Multiplying out, we get u to the fourth minus u squared du. Of course, this is u to the fifth over 5 minus u cubed over 3 plus c, which means our antiderivative would be cosine to the fifth of x over 5 minus cosine cubed x over 3 plus c. And in general, when you have cosine and sine both raised to powers, whichever one is odd, that one is going to serve as the du part. And if they're both odd, you can pick either u equals sine or u equals cosine. They'll both work. If they're both even, then you're going to have to resort to using double angle formulas and the power reducing formulas.